The simple machines. What do you use when you want to cut a paper, open a bottle, or slice a piece of fruits? How do different materials you use help you? When you cut or slice fruits and vegetables, or even open a can or bottle of soft drinks, you use simple machine. Everyone uses simple machine every day. Schools, industries, and businesses uses simple machine. Clinics, hospitals, and laboratories use machines to serve people. Cars, ships, and airplanes use machines to transport people and goods over great distances. It is difficult working without machines. Machines, whether it is powered by engine or powered by people, it always make working tasks easier. These are the kinds of simple machine. Number 1. Inclined plane. Number 2. Wedge. Number 3. The screw. Number 4. Wheel and axle. Number 5. Pulley. Number 6. The lever. You can cut a paper perfectly using a pair of scissors. You can join easily two wooden planks using hammer and nails. Scissors, a hammer, and nails are examples of simple machines. What are simple machines? What are their parts? How do machines actually help us? These are the questions that we are going to answer on our lesson. Machines are used to transfer energy, multiply speed, and change the direction of the force. Simple machines do work in one movement or a one type of work-easing device. Machines can be classified as simple machines and compound or complex machines. Simple machines are simple tools that multiply the amount of force to make work easier, while compound machine consists of multiple simple machines in one device. Bicycles and sewing machine are examples of compound machine. Now let's go to all the details of all kinds of simple machines. Number 1. The inclined plane. It is a flat supporting surface tilted at an angle with one end higher than the other. It is actually used in raising and lowering loads. An inclined plane lessens the effort exerted over a distance and changes the direction from straight up to along the angle of the plane. Look at this diagram. The lesser the angle of the inclined plane, the longer the distance, and the lesser the effort is needed. Inclined planes are widely used in form of loading ramps to load and unload goods, like for example, on ships, airplanes, and on trucks. Wheelchair ramps allow people on wheelchair to get over obstacles without exceeding their strength. Did you know that the inclined plane has been used by prehistoric times to move heavy objects? Romans used inclined plane for moving heavy things uphill. The heavy stones used in creating ancient structures such as Stonehenge. These are believed to have been moved and set in place using inclined plane. Now, here are the other examples of inclined plane. Number 2. Wedge. A wedge is a double inclined plane that is sharpened to an end. It can be used to separate two objects or portion of an object. It can also be used in lifting up an object. Wedge can also be used on holding an object in place. Remember, the thinner the wedge is, the lesser effort is needed to cut objects. Therefore, the thinner the wedge, the sharper it will be. Here are some of the examples of wedges and how are you going to use it. Number 3. Screw. A screw is another modified inclined plane. A screw is made when an inclined plane is used to wrap a cylinder. The spiral ridges of the screw are referred to as thread, and the distance each thread is referred to as pitch. And these are the parts of the screw. A jack screw, for example, is used in lifting heavy cars. Now let's take a look at the example of screw or objects with a screw on it. Number 4. Wheel and axle. The wheel and axle refer to the assemble formed by two discs of different diameters mounted so that they can rotate together around the same axis. The wheel is fixed to the axle. Forces are applied to the edges of two discs to provide mechanical advantage. To move the load of the axle, the user needs to apply effort to the larger outer wheel. The mechanical advantage of a wheel and axle is equal to the radius of a wheel divided to the radius of the axle. Usually in wheel and axle, the radius of the wheel is much bigger than the radius of the axle. So, the distance over which the effort is applied is greater than the distance of the load which is placed at the axle. Now, the gear mechanism on your bicycle multiplies the distance that you travel. Do you think it has something to do with force? Now, here are the other examples of objects where we use and observe wheel and axle. Number 5. Pulley. A pulley is a modified wheel and axle. It is used to lift loads, apply forces, and transmit power. A pulley has a rope sliding on the groove of the wheel. The groove prevents the rope from slipping. The axle, on the other hand, serves as the mounting bracket that attaches or holds the wheel so that it turns as the rope slides. Before showing you some examples of pulleys, let me tell you that there are 3 kinds of pulleys. These are fixed pulley, movable pulley, block and tackle. A fixed pulley is generally hung, making the pulley and wheel stationary in position. It can lift an object easier by changing the direction of the effort force. A fixed pulley is usually seen in flagpoles, or the parts of the wheel that pulls a bucket of a water on a well. A movable pulley is a complete opposite of fixed pulley. The entire wheel together with the axle of the pulley travels along the rope. A movable pulley is hung on a rope and hooked to a resistance. Zipline, for example, use a movable pulley to deliver a person from high area to a low area. Block and tackle. It is a combination of fixed and movable pulley. The fixed pulley is the part that pulls a movable pulley. The movable pulley therefore carries the resistance, as the fixed pulley is where the effort is exerted. This block and tackle combines the direction changing ability of the fixed pulley and the force multiplying ability of the movable pulley. Block and tackle are usually used in construction areas for lifting heavy metals and heavy loads. Number 6. Lever. A lever is composed of a straight or bent rigid bar that is free to turn in a part known as fulcrum. It is actually a simple machine that you can easily find anywhere. These are the parts of a lever. The resistance or load. It is a force that is being lifted by the effort. The effort. It is a force lifts the resistance. The fulcrum is the fixed movable point where the rigid bar moves. Classes of levers. There are actually 3 classes of levers, varying on the placement of effort, resistance, and fulcrum on the object. The first class lever. The parts placement are resistance, fulcrum, effort, or effort, fulcrum, resistance, depending on how you look at the object. In first class lever, the fulcrum is between the effort and the resistance. Here are the examples of first class lever. Second class lever. The parts placement are fulcrum, resistance, effort, or effort, resistance, fulcrum, depending on how you look at an object. In second class lever, the resistance lies at the middle of the fulcrum and effort. Now take a look at the examples of second class lever. Third class lever. The parts placement are fulcrum, effort, resistance, or resistance, effort, fulcrum, depending on how you look at the object. For third class lever, the effort lies at the middle of fulcrum and resistance. Well, the third class lever is actually similar to a human forearm. Now here are the other example of third class lever. And these are the kinds of simple machine. I hope you learned something.